Hello, it's Ms. DeLulo here, and today we are going to learn about the properties of powers. This is in our goal, which is to know and apply the properties of integer exponents. Here's an example of a basic power so that we can review some vocabulary that we will be using throughout the lesson today. The 3 in the corner is known as the power or the exponent. The 5 in this case is known as the base. And what our power or exponent tells us is how many we have of a certain base. In this case, we have 3 5s, which means we would be multiplying 5 3 times. Since in this case our base is a number, we can evaluate this, and this would equal 125. Our first property is the product of powers. The product of powers states that if powers of the same base are being multiplied, then we add the exponents. So in this first general example, we have the same base of x. So that means our base, when we add the exponents, will be x still. The base does not change. We just simply add our a plus b. So that is our general form. In example 1, we have a bunch of y's. So all of these y's show us that we have the same base. So we can add the exponents from each of the y's in order to simplify. Our first y has an exponent or power of 2. The second y has a power of 1. And the third y has a power of 4. So we'll be adding y to the 2 plus 1 plus 4. This tells us 2 plus 1 plus 4 equals 7. So that means total we have 7 y's. Each of these property boxes has an example or two for you to try on your own. In this case, you'll be multiplying x cubed times y times xy to the 8th. Once you try this on your own, you'll notice that on the right, the answer to the you try is in the column on the right. So you can check your answer as you go. Make sure that you write down any questions that you have or if you had difficulty getting the correct answer. Our second property, the quotient of powers, states that if powers of the same base are being divided, then we subtract the exponents. So in this general form, we have x to the a divided by x to the b. Since these have the same base of x, we are going to subtract their exponents, which would be a and b, so we now have x to the a minus b. In example 2, we have x's of the same base, so that is going to be our base, and then we simply subtract our exponents, 12 minus 4, so this becomes x to the 8th power. In this second example of example 2, we first notice that we have an x. Now there are no other x's in this problem that we could possibly combine our exponent with. So we're just going to carry x squared over. I do notice, however, that I have z's in common. So that means I can combine my exponents from the z's. I can take z to the 10 minus 3. So when we simplify this, we have x squared times z to the 7th. Our third property is the power of a power. If a power is being raised to another power, then we multiply the exponents. So notice in this case that our inside the parentheses is considered now a base to the exponent b. So we are going to multiply our a times b because this base x to the a is being raised to the b power. So in example 3, we have w cubed on the inside. So since we have a power on the inside being raised to a power on the outside, we're going to multiply that 3 times 5. So our base, our w, carries over, raised to the 3 times 5, which will become w to the 15th power. Our fourth property is the zero power property. Any base or power raised to the power of 0 is 1. So in this case, we have our base of x raised to the power of 0, so our answer is 1. In example 4, x to the 6th power is all being raised, this whole thing on the inside is being raised to the power of 0 on the outside. So this is going to be 1. In the second example, for example 4, we will show a little bit more why you get 1 when we are going to use the quotient rule. So we have two y's, so since we have these two y's, we can subtract their exponents because they're being divided. So we'll have y to the 1 minus 1. We have our two z's, and we can also subtract their exponents since they are being divided. So z to the 4 minus 4. So y to the 1 minus 1 is 0, z to the 4 minus 4 is 0, and we know that anything to the 0 power is 1, so we now have 1 times 1, which is equal to positive 1. Our fifth property is the power of a product property. If the product of two or more bases are being raised to the same power, then we distribute the exponent to each base. So in our general form, we have an x times y, all raised to the 8th power. In this case, our bases are different. So we are going to distribute this power to each base. So this will become x to the a times y to the a, and that would be as simplified as that can go. In the example here, we have 2x all raised to the 4th power. So that means each term inside this 2x, the 2 and the x, will both be raised to the 4th power. So we have 2 to the 4th times x to the 4th power. Since 2 to the 4th power has a base that is a number, we can evaluate 2 to the 4th, which will be 16, and then just carry over our x to the 4th. Here we have the power of a quotient property. If the quotient of two bases are being raised to the same power, then we distribute the exponent to each base. So we have x divided by y, which are two separate bases, so we need to distribute that power of a to each base. So this would become x to the a divided by y to the a. In our example, again, we have x and y now being raised to the 2nd power. So we need to distribute that 2 to each base. So this will become x squared divided by y squared. Our last and final property is the negative exponent property. If a base is being raised to a negative power, take the reciprocal of the base being raised to that power, and then the exponent becomes positive. So in our first general formula, we have x to the negative a. I can write x to the negative a as a fraction over 1. If I'm going to take the reciprocal, I'm going to flip my numerator and denominator, and so x to the negative a over 1 becomes 1 over x as the reciprocal, and then our exponent, negative a, carries to the bottom and now becomes positive. In the next form, we have its inverse, x to the negative a. So now we are going to instead move x to the negative a to the top and our 1 to the bottom. Our x to the negative a on the bottom will move to the top and become a positive a. So in our first example, x to the negative 3, we are going to have first make this into a fraction so we can easily identify its reciprocal. X to the negative 3rd power will flip to become 1 over x. Our negative 3 exponent carries to the bottom with the x and becomes a positive 3. In the next example, the only part of this expression that is being raised to the negative power is the x. The 4 does not have a negative exponent, so we're actually going to leave 4 right where it was. The only part that will move to the bottom is the x to the negative 8th. So our 4 stays on top while our x moves to the bottom, and then our exponent of negative 8 also moves to the bottom and becomes positive. So now we have 4 over x to the 8th. And in our third example, again, we have to check and make sure that we're only moving the terms to the bottom that are actually raised to a negative power. This y is raised to a negative 5, the x to a positive 2, and the 3 to a positive 1. Just because our coefficient has a negative in front does not mean that it's raised to a negative power. So, in this case, just our y to the negative 5 is going to move to the bottom. Our negative 3x squared stays on top, the y moves to the bottom, and our negative exponent of 5 becomes positive. Here are a few other problems for you to try with the answers on the side for you to check. Make sure you write down any questions that you have or confusions that you had during the video. And as always, thank you for watching.